Hello everyone. In this video, we're going to be solving a homemade exponential equation. We have e to the power ln x squared plus x to the power ln x equals 2e, and we're going to be solving for x values. Now, I call this problem homemade because I thought about this idea. There is a really nice identity behind this, which I'll share with you in a little bit. But these problems are not that hard to come up with, so I highly encourage you to do it because writing your own problems is really fun. Anyways, so we have this equation and we're going to be solving for x, and I'll be presenting two methods. Okay, let's start with the first one. So my first method is going to use substitution because why not, right? Substitution is fun and you should always try to use it. So I'm going to go ahead and call ln x something because when I look at a problem like this, first of all, I got to tell you that this problem is pretty non-standard, don't you think? Well, at least on the surface, it looks that way. Because look at it. We have e at the base and then we have x. There are different bases. And then you're adding them. And how do you solve that type of equation? I mean, having e on the right-hand side doesn't really help right away, at least, before we do something else. So this problem kind of looks complicated, right? But if you don't look at it deep enough. Now, if you go ahead and use substitution, let's say set ln x equal to t. I use t a lot, by the way, right? I drink tea a lot too. And you're going to get something like this. Replace ln x with t. So we have ln x here and we have ln x here. But what about x, right? We also have to replace it with something. So from here, if you consider the fact that ln means natural log, right? Unfortunately, Wolfram Alpha writes it as log, log, but that's what I use for base 10. Anyways, this is base e. So by using the definition of logarithm, from here we can write x as e to the power t. Awesome. That's something I can substitute here for x. Let's do it. ln x replaced with t, e to the power t squared, plus x replaced with e to the t, and then raise it to the power ln x, which is t, equals 2e. Okay, 2e or not 2e. I guess that didn't work. It's not like 2b. So anyways, what do? Now we got the same base, which is cool. Substitution really helped. And then we can go ahead and now use the properties of exponents and multiply these two exponents. That gives us e to the power t squared. And guess what? You get the same thing twice, which is amazing, right? I mean, especially for these kinds of problems, it will be awesome. And now we can write this as 2 times e to the power t squared because you're kind of adding like, you know, something plus the same thing. That's going to be 2 times that, and that's equal to 2e. And that's awesome because now you can go ahead and cancel out the 2's, right? Divide both sides by 2, you're not canceling out any variables, which is good because that could cause a loss of solutions, right? You got to be very careful about that. And of course, you could also cause some extraneous solutions, or not really extraneous, but most of the time it's going to be like a loss. Anyways, we get e to the power 1, which is e to the power t squared equals e to the power 1, and this implies t squared equals 1. And that implies two things, right? One of them is t equals 1, and the other is t equals -1. Wait a minute. We have the log. And if you're looking for real solutions, can t be negative? And the answer is yes, because t has nothing to do with logs. Well, sort of. It's on the other side of the log, so it's good. We're safe. So remember what we call t? It's ln x. So ln x is equal to t. So now we can go ahead and take these two expressions and set them equal to ln x. So t equals 1 equals ln x. From here, we're going to go ahead and solve for x. And to do that, again, we're going to use the definition. Think about it. E to the power 1 equals x, or x equals z. You can also think of it this way. Log a with base a is 1, right? And so when would you get 1 from ln? When the argument is e. In other words, ln e equals 1. You see, by repeating these things, I know sometimes I'm being repetitive or redundant, but the idea is to help you remember these things and, get these things hopefully stuck for long term. Anyways, x equals e is one of the solutions. And for the other one, t equals -1, which is equal to ln x. Same idea, e to the power -1, that's going to give you x equals 1 over e, because e to the power -1 is just the reciprocal, right? So looks like we got two solutions, e and 1 over e. Let's see how we can solve this problem using the second method. And I'm curious if there's a third way to solve it, and I'm pretty sure you're gonna let me know in the comment section down below, right? Okay, great. Let's see how this proceeds. We have e to the power ln x squared plus x to the power ln x equals 2e. Great. Now, you'll probably see the idea behind this problem when I show you the trick, because that's actually how I came up with the problem. So obviously, when you come up with a problem, it's not only fun, but also kind of rewarding, because you kind of get to share your insights, like, how can you identify these tricks, right? Obviously, if you know the trick beforehand, it's easy, but by practicing, you're going to get better and better. So don't never despair, okay? For those of you who say, oh, this is too hard for me, I can't do it, never ever despair, because everybody was at that point at some time. So you'll get better and better if you keep practicing. All right, so how do we handle this? So we're going to look at it from another perspective. Obviously, I'm not allowed to use substitution because I already used it. So I'm going to write it as follows. Notice that ln x is squared. That means ln x times ln x, right? Sometimes people are going to write it like ln squared x, but I don't think that's pretty standard. Sometimes people will write log squared, just like sine squared x. I don't think that's commonly used, but if it is, that's what it means, right? But I rather put that in parentheses to make it more clear. Now, this means ln x times ln x. Great. But what is so great about it is that you can actually use properties of exponents. Whenever you have a to the power m to the power n, it's a to the power mn. And you can kind of reverse the process. Whenever you have the product of two exponents, you can kind of put one of them inside the parentheses. Make sense? Kind of like factor. So this can be written as e to the power ln x to the power ln x, nice, plus x to the power ln x equals 2e. And now notice that inside the parentheses, we have something real cool. You know what that is? It's an identity. If you know the relationship between the exponential and the logarithmic functions, they're inverses of each other. Therefore, this is going to be equivalent to x, right? Of course, in the real world, x needs to be positive, so on and so forth. And if you notice, with the first method, we found two values. Let's not disclose it, right? For those of you who just started with the second method, we don't want to give it away, but this is equal to x. And then what happens is something just amazing, right? Because now you get the same thing twice, same idea, but without substitution. I really like it because what follows is also cool. Divide by 2, you get this. And now we don't get x right away, do we? You can use substitution at this point if you want, but there's actually a cooler way to approach it, which is natural. I wasn't supposed to use that color. It was supposed to be blue. So let's go ahead and natural log both sides. Beautiful, right? Now, when you do it on the right-hand side, you're going to get 1. And here we have this property that this jumps up and comes to the front. So you get ln x times ln x, which is ln x squared, which is going to bring us back to the first method because we use substitution with that, right? We arrive at the same result, of course. From here, x equals e. From here, x equals 1 over e, or e to the power -1. And this brings us to the end of this video. Thanks for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.